Welcome back to Further Solutions Academy. Further Solutions Academy. I encourage us more to share to your friend and also subscribe. If you have not subscribed before, just press on the subscribe button. We have over 250 videos for everyone here: mathematics, physics, and chemistry. They are very well explanatory enough. And if you are expecting a topic to be available for you, which is not there yet, you are free to leave a comment below. Or you reach us, contact us with this line. Now, with this line, you can call us, you can WhatsApp us. You can also Telegram us. Now, with this, you can do 3 things with this line. Now, I have this, which is called electric field intensity. Now, electric field intensity. That's what I have for you. The first thing I'll be working on the definition of this electric field intensity, and also the problems on it. Now, let me start. Now, electric field intensity, which is E, also known as the strength of an electric field at any point, is defined as the force F expressed by a unit positive test charge, which is Q, at the point. It means my electric force will be equals to electric charge multiplied by electric field. Now, it means my effort is equals to Q of E, which what I mentioned here. Now, it means therefore my electric field intensity will be equals to, which is let me use my E equals to force all over charge. Now, that is what we are talking about on this part. That's what we are talking about on this part. Now, we can also rewrite this in terms of, we all know what, okay, we can say that, or in this form, my E equals to Q all divided by 4 pi E naught, or my E equals to K of Q of R squared, which I've explained in our previous video. Before you watch this video, make sure you watch the video before this. Very important. The unit of electric, the unit of electric field is a Newton per coulomb. Newton per coulomb. Please take it to that. Newton per coulomb. That is what I know about electric field. Don't forget that we are talking about what the electric force equals to electric charge multiplied by electric field intensity. And I've told you earlier that my charge is always on Q. My charge is always on Q, which is electric field intensity is denoted by E. Note that. Now, let me give an example on this part that will help us to at least to have confidence in any of our exams. Okay. Now I have this problem which it really help us to get this part very well. In a uniform electric field, the magnitude of the force on a charge of 0.2 coulomb is 4 Newton. Calculate the electric field. Now I have this problem to solve. Solution. How do I solve this problem? Now I know my force, which is F is 4 Newton. What else do I know? I know my charge. My charge we all denote it by what? By Q, which is 0.2 coulomb. Now, and I've told you earlier that my electric field intensity, which is E, equals to F all over Q. Now, it means I don't need to stress myself. It will be force, which is 4 Newton, 0.2, which is my 4 divided by 2 all over 10, which I have 4 multiplied by 10 all over 2. Year 1, year 2, which is 20, which is I'll be having 20 Newton per coulomb. That is my answer. 20 Newton per coulomb. Now, okay, I have a lot of problems to show here that will really help us. Now I have another question, which is calculate the magnitude of the electric field intensity in vacuum at a distance of 2.25 centimeter from a charge of 5.5 multiplied by 10 coulomb. Take 4 pi as 4 multiplied by 10 raised to power 9 Newton squared coulomb squared. Now I have this problem to solve, which is a very simple one. Solution to this. Now, what should I do? The first thing I will have to do is, what did I have? the first thing I have is distance. I have distance from the problem, which is known as R, as 25 centimeter. Now, I can't use centimeter, I've told you is not on standard, which I'll convert this to what? To meter, which it will be 0.25 meter. Now, that's what I'm using. Next thing I'll be talking about my charge. My charge, which is my Q, it will be equals to 5 multiplied by 10 raised to power 3 coulomb meter squared per coulomb squared. That is what I'm having there. Now, yes. Okay. That is that. I didn't pretend the question very well. Now, since I have that, I cannot continue by having my E equals to quantity, charge all over constant K, which is of this, which is divided by, normally it's supposed to be 1 divided by, multiplied by quantity all over, charge all over distance squared. This is how it always be. Now it means I've have a number for this, which is from the question. I have 5.10 raised to power 3 multiplied by 10, 9 multiplied by 10 raised to power 9 divided by 2.5 squared, which my calculator will be of help. Okay, with the help of my calculator, to be 7.2 10 raised to power 8 Newton per coulomb. That is my answer. That is my answer. Now, I have another one. 2 point charge of magnitude plus 20 10 raised to power minus 8 and coulomb, and minus 5 times 10 raised to power minus 8 coulomb are as separated by a distance of 10 centimeter in vacuum as shown in the diagram below. Now, what is the diagram? This is minus, okay, we have plus 20 10 raised to power minus 8, and I have minus 5 times 10 raised to power minus 8. Okay, coulomb. And this is a point. This is a point. I have this as point P. Now, this is 5 centimeter. 5 centimeter. Now, Yes, okay. 1. Field at P due to Q1. Due to Q1. Okay. That presentation of nuances. Now calculate 1. The electric field intensity at a middle way between the charge, which is 2, the force on A minus 4 times 10 raised to the power minus 8. At P. Take equals to 9 multiplied by 10 raised to the power 9 Newton meter squared per coulomb squared. Now, this is what I have for you. Now, let's see how this question will go. Solution. The first thing we need to know here is that we need to think about, firstly, number 1, field at P due to Q1. It means I'll be having E1 equals to Q1 divided by 4 pi, which is 1 over r squared. The same thing we're just talking about here. It means we're just moving on. Now, which it implies, which is, I have my Q, which is my Q is quantity of charge is this, yes, which is this, which is, I have it as 20 times 10 raised to the power 8 minus 8 multiplied by, what is here, we have it as 9 multiplied by 10 raised to the power 9, all divided by this r, my r, which is my distance. My distance is 0. This is 5 centimeter, which is, convert this centimeter to meter, which is only 0.005 centimeters meter square. Now, by so doing that, press your calculator. We have it as my Q1 will be equal to 7.2. Mind you, I use my calculator. I have my calculator here, which you also need to use the calculator so that you are able to get it right. Okay, and multiply by 10 raised to the power 10 Newton centimeter. Newton per coulomb. Now, by so doing that, I've gotten my Q. The electric field intensity at 1, which is 1. I'll move on to the second one, which is I'll have my field. Now my 2 will be equals to the same way, which is I'm having Q2 divided by r squared multiplied by 1 all over 4 pi naught, which we all know this as this, which I have Q E2. What is my E2 to be minus 5, which is I have it as 5 multiplied by 10 raised to power minus 8 multiplied by the next thing is 9 multiplied by 10 raised to power 9 divided by my R is still remain at as 5, which is 0.05 squared, which by so doing that, make sure you correct your calculator. You have it as 1.8 10 raised to power 5 Newton per. Now I have that. Now I will now look for the resultant field at point is the resultant. We don't know what is called resultant. The resultant field at F is E1 plus E2 is E1 plus E2. Now we all know what is our E1. Our E1 is which is going to be 7.2 multiplied by 10 raised to power 5 plus 1.8 10 raised to power 5, which is I'll be having it as Newton. Now with this I will have what I need, which is to be added up to be 9. To be 9. This is going to be 9 times 10 raised to power 5. That is my answer for that. That is my answer to that. Now, the next one, which is the second question. The second question, sorry, let me rub this part. I have this, which is the field is directed towards the minus 5 10 raised to power 10 minus 8 charge, and Q equals to minus 4 10 raised to power minus 8 coulomb. Now my E will be equals to 9 multiplied by 10 raised to power 5, which what you just got to now. We just get that one now, which is there. Now it makes my force, which is my F, which will be equals to Q of E, which I'll be having 4 multiplied by 10 multiplied by 10. Multiplied by 9 raised to power multiplied by 10 raised to power 5, which calculator will be of 9 times 4. We have 36. Okay, I have 3.6 multiplied by 10 raised to power minus 2 Newton. That is the force. That is the force, which is number 2. Number 2 of this question. Number 2. With this, you can see that is very, very simple, which I'll be stopping here. I'll be stopping here. Don't forget, okay. Don't forget that you are on with further solutions. Further Solutions Academy. Share and subscribe. Share and subscribe. And mind you, if you want to drop any comments, you are free to do that. And also, you can drop message on our email, or you contact us with this number 2348034495990. In this line, you can call us, you can WhatsApp us, and also via Telegram is allowed. Either of the three. Once again, thanks for watching.